And hello everyone, welcome back to another Love2D tutorial. So in the previous tutorial, we did some setup on our Love2D program. So if you haven't seen that tutorial, I highly recommend you do, because we cover a lot of interesting topics or important-ish topics, such as creating this conf file where we set the app window and height as well as the title, and discuss whether or not you need to set the window display to 2. And in here, we have just set up our basic Love2D file. So currently what we have isn't a lot. If I were to run my program here, then we'll just have this. It doesn't really do anything. So yeah. First thing I want to do is I want to hide my mouse. So when I'm here, the mouse should be gone. Now that's pretty simple. To do that, we can go here and say love.mouse.setVisible, and we can just go false. And this will set the mouse visibility to false. Now for future reference, we're not going to do that in this tutorial, but it will be smart to set our mouse X, mouse Y equal to 0, or whatever you want to here. So these will be two global variables containing the mouse X and Y positions. This is for a future reference, so you don't have to put it here now, but I do recommend you do, because then we don't have to worry about it. And then next up, here in the update, we also want to set the mouse X and Y. So I will actually just copy this, paste it here, and then here we can go love.mouse.getPosition. And this will return the X and the Y position of the mouse. Both of these are global scope. So if you wanted to, you can go _g dot, and that would be allowed. But for me, here I'm just going to say quick fix. And if you're in VS Code, you can choose one of these. And I'll just go here, disable diagnostics for lowercase in this file. Or even in this workspace could work, but I'll go file. And it will add this where it doesn't show that errors underneath these. And then last but not least, before we continue, I would like to set the show debugging equal to true. And this will basically say if we want to see debugging items. Right now we're not going to use it, but we will later. If we run this, you can see I can no longer see my mouse, but if I move outside of the screen, you see here, there's my mouse, but if I go in, it's gone. That is what we wanted. Cool. Now we can create the player. To do that, we can go here and create a new file called player.lua. I'm using a capital case P just because I believe objects, or at least other files, should use capital case P unless it's the main files or the core files going to be used by Lua, like the conf or the main. Cool. Now the player here will be an object. If you don't know how to work with objects in Lua, I do recommend you go watch my objects tutorial I have on this. Then you can go local love equals require, and then love. And if you want to, you can copy this and you can put it in here. Take note that this diagnostics only works if you're in VS Code. If you're in a different IDE/code editor, then this may not work. Now we can create a function, call it player, and player will take in whether the player is busy being debugged, so debugging. So if we're debugging the player, then we want to see some extra information. And then at the end of the file, we can say return player. Nice. Now, some variables you might want to set at the start will be the ship size. These will be constant variables that will never be changed, so they are capital case. And we won't want to access them outside of this file, so we're not putting them inside of the return. We can make this equal to 30. You can change this, but this will basically determine the ship size, because this would be from the left side of the ship to the right side of the ship. Then we can go local view angle is equal to math.rad 90. To get an example of what this does, because it transforms degrees into radians, because we want to use radians and not degrees. So to understand what we'll get here, we can go here and say Lua, and then say math.rad and then 90. And that will give us 1.57 radians. So yeah, we're going to use radians, not degrees. Just keep that as note. So this would be 1.57 radians. And it's all to do with math stuff, so don't worry too much about it. Then here we can say debugging is equal to debugging or false. So if we do not pass in the debugging argument, then by default it will be false. That's what we are saying here. Now return is what we want to get back, what we want to be able to access within this whole thing here. So x will be the player x position, which is love.graphics.getWidth divided by 2. So we want the player to be positioned in the center of the screen once the game starts. So that's what we're doing here. We can then do the same for y, and then y instead of getWidth would be getHeight. So now the player will be positioned in the center of the screen. Then the radius of the player, and this will kind of be like the hitbox of the player. So the circle around the player, if that circle is hit, what happens? Anyhow, so the radius will be the ship size divided by 2, and then the angle will be equal to view angle. So the angle by default will be 90 degrees, meaning the player will be facing upwards. How do I know that? Because the player will be a triangle. If you've seen the demo of the game in the first tutorial, I showed you that the player itself will be a triangle that moves around. And if the angle of the triangle is 90, in terms of degrees and a radians 1.57, then it will point upwards. Cool. Then rotation will be equal to 0. So this is if the player has been rotated. Then thrusting will be equal to false. If the player is thrusting, that means we want to move because he's thrusting, is blasting out fire and stuff, which we won't code in this tutorial, but we will code later. And then the thrust itself will be equal to the x 0 and then the y 0. And I'll explain what all of this means later once we get to it. And then the speed 0. Cool. Now this currently won't do anything. So let's draw the player to the screen. So underneath this thrust, we can just create a function called draw. This will be a function that takes itself, and then here we go. Now local opacity is for future reference, but basically this will determine how visible the player is to the screen. So if the player is on the screen, can we see the player or not? Next up, we want to say love.graphics.set color and then 111, and this means white, and we pass in the opacity, which is also 1, so it means it's completely visible. To draw the player, we can say love.graphics.polygon, and in here we can type in a lot of things that will draw the player. First of all, we want to draw the player as a line, not as something that's being filled in. So we can say line. So it's going to draw lines. Then we want at least 2 items to draw that line. So let's go self.x plus, and this will be a little bit of math, so bear with me. And we have 4 divided by 3, and note I'm using 2 brackets here. This is just for me to know, okay, I want to do the division first. The computer will know, let's do division first. But I want to know as well, let's do division first. Because when it comes to math operations and when to execute them, I am still a little bit junky on that. And we can say times self.radius. Take note that this is not inside of these brackets, inside of this bracket, but not inside of these brackets. Because we want to execute this first. So 4 divided by 2, and I think that should be 3. And I'm going to explain this in a second. And then times the radius. And then once that has completed, we want to times that by math.cos self.angle. Now the 4 divided by 3 is mainly to find the center of the triangle. Next up, here we can say self.y, so we can copy that line, say self.y, keep everything the same, And in here, instead of saying cos, we say sin, because we want to go the other way. So let's create the player and hope for the best. So then here we can say local player, capital P, is equal to require player. And there should also be a capital P, because the file has a capital P. Then down here in the loading section, we can say player, lowercase p, is equal to capital case P player. If you don't understand what I'm doing, I recommend you to go watch my course on OOP in Lua. And then we can also pass in show debugging. So this will create us a little object of player that we can use and get data from. Now here we want to just see the player. So let me just draw player : draw. How can I use this? Because right here we export the draw function. It's inside of return. And then it should draw the player for us. Now if we were to run this, do we get? No, we don't. It needs at least 3 vertices to draw a polygon. Oof. Okay, so we'll have to draw the whole thing, unfortunately. But okay, not a problem. So since there's a lot of typing, I'm just going to paste this here, and then I'll walk you through it. So basically, here we have what we just coded. And in here we say self.x minus the radius, right? Times 2 divided by 3 times math cos self angle. So first we're going to times this because BODMAS. If you want to make sure of that, you can do that. Anyway, so we'll first times these and then we'll add this to it. And it's going to be the same all the way around for x and y. The only things that change is when sin and cos is being used. And yet again, I don't quite understand this math. It was a 1 a.m. thing. So just excuse me if I don't quite know how to explain this. But you can play around with it if you want to understand it more. I don't really want to understand it more because it breaks my brain not understanding it. So I'm scared of understanding it. Anyways, if we try to run it now. Aha, here we go. Doesn't quite look like the player. So let's see what went wrong. Oh, you know what went wrong? Here we should minus it. My bad. Now, if we run this, we'll get a triangle. Cool. If you want to actually test it out for yourself and see how it looks, what you could do is you could run Lua and then open up a drawing application. Okay, now there is our x position and our y. So x would be side to side, as you know, and y would be up and down, as you also know. To remember this, you can remember y has like this little finger that goes like that, and you can add arrows here to specify up and down. That's how I remember which one is x and which is y. Anyhow, so there's our center. Then what we can do is, let me just do that. So first we get our self.x, and let's say x itself is equal to, what is it? Okay, let's make it 20 or 200 because that would be more realistic. So 200 plus, and since we know this isn't going to execute yet, let's first go 4 divided by 3. 4 divided by 3, that's 1.333. So 1.33333 times, and then the radius, as we already know, is, let's see here, ship size, that's be 15 because ship size divided by 2. So the radius would be 15, so times 15. So this right here is basically 20. So that's 20. Then we times this with math cos and then the angle. And this is why we used radians right here and not degrees. Because if this was 90 degrees, then this would be way off. So we are using radians to give it a much smaller value to work with. Because 90 would be pretty big compared to 1 point something. Anyhow, so then we can say math.cos. And in here we can specify the angle. And the angle, as we know, is math.rad90. So math.rad90, like that. Okay, so we got our values. Now we have to times these two together. So 19.99999 times 6.1232339, I believe. That will give us this right here. And then we can add our self.x, which would be 200. So this value right here plus 200. Now that we have that, we can see where the next dot will be drawn on the x-axis. So here we have our x, and this right here, that's 200 to the x. So that's 200. Now the next one will be 322. So that would be even further beyond. So that would be like here or something. And not downwards is just the X part. So like it would be like here or something. There. And this is where this one is. And you can just imagine that these two are 120 pixels from each other. Now with the Y, it will position this one downwards. So you can use this to kind of figure out where everything goes if you were to do the math like this. This is at least how I can understand math. So if I want to spend the time, this is how I would understand it. So we can draw the player. That is good progress. We can't do anything yet, but we can draw the player. Nice. Now, we still have a debugging option. So let's quickly implement that. So right underneath opacity, we can say if debugging, then, and here we can say love.graphics.setColor. And you can make this any color that is not white or black. So 1, 0, 0. Because black is the background and white is the color of the ship. So making it a different color will make it easier to see. So in this case, I'm making it red. And then love.graphics.rectangle. And we want to actually see the center of the ship. This will just help for debugging for when we try and move the ship and the ship maybe doesn't move, but the center moves or something like that. And here you can just say fill and then self.x minus 1, self.y minus 1, 2, 2. So this positions it in the center. And I'll show you in a second what this means. So if we do this, as you can see, we have a little red dot in the center of our ship. The reason I said -1 for the X and the Y position was because if I didn't, we'd be getting this. And as you can see, it's a little bit off from the center. And we don't want that. And the reason for that is just because of how we draw. So we add -1 to avoid that. And in the 2 is just the size. So if we were to change this to 4, for example, then now we'll get a bigger circle. And now we'll have to change it more to the side because of the size here. So this will now have to become -2, -2. So the more you increase the size, the more you have to move it back. Because you have to remember, if I were to open my drawing app again, if we have a square like that, this is the X position of the square right here. So right there. That's the X position of the square. And we are drawing a rectangle inside of the player. So we need to minus this to the X and minus to the Y to bring this to the center of this square. If you understand what that means. Anyhow, so let's just change back to 1 and to 2. And then next I want to draw the collision of the player. So when we try and collide with other things, we can see where the collision would affect each other. So love.graphics.circle, and here we can say line self.x, self.y. We can say self.x and self.y because the X and Y of a circle is in the center of a circle and not at the side of a circle. And it's self.radius, so the radius of the ship itself. If we run this, we get a circle around the ship. Now this circle right here is basically the collision. So if anything touches that circle, it's touching the player. You might think this is pretty basic and it is moving things and it isn't quite accurate, but believe me, this does decrease the amount of math we have to do, and you'll thank me for this later. Alright. Now, whenever you don't want to see that, you can just turn off the debugging by passing in false here. Cool. Now, let's move the player. Because currently the player isn't moving at all, and we can't move the player even if we wanted to. So let's create a function, and we can call the function move player, or just move. Both will work perfectly fine. We can then say function that takes in self, and then local FPS. So this will get the FPS of the game. So this isn't the best way to say how fast the player should be moving. And we could possibly change this in the future to be a better way. But for right now, saying the FPS will be the easiest way. So we can say love.timer.getFPS. And we can of course scroll a bit down. And then we want to set the friction, and the friction will just basically say how fast the player should stop moving. So let's go here and say local friction, and we'll play around with this because it's pretty simple. is equal to 0.7. Now we need to set the rotation speed of the player. Now I want the player to be able to turn a full 360 degrees, so completely around within a second. To accomplish this, we can say self.rotation is equal to 360 divided by 180 times math.pi divided by FPS. So first, there we go. So first it will execute this, and it will get the value of this. So Lua 360 divided by 1080, that's 2. Then it will divide these two, so math.pi divided by FPS. So math.pi, and we can assume we'll be getting 60 FPS. So that's 0.052. So that's 2 times 0.05235, like that. And that should be a times symbol, not an and. And they will get this value right here. Now this value right here is basically how much the player will turn every second. Cool. Now let's actually use that, because I think it would be easier to understand if we use it. And don't worry too much, there won't be that much math in this course. It's just the first one has quite a lot of math because we're using a triangle and whatnot. So you don't have to worry too much about the math. We want to basically say when the player should be turning left and right. So to do that, we can go here and do a quick fix to that and say love.keyboard.isDown. And we want the player to turn left whenever they click on the A button. And you don't have to add these extras, but I like to add options. And we can say, or if they press the left button on their keyboard. So that's like the left arrow on your keyboard. Or if they press the KP6, and that's the numpad number. See, and that shouldn't be 6, that should be 4. So that's numpad number 4. So if they're on the numpad, they press 4, then the player will also go. So now they have a lot of options to choose from. You don't have to add this many. I just like to. And you can say self.angle is equal to self.angle plus rotation. So every time this runs, it will add this to the rotation. So it will add 0.1047 to this right here, and that should be self, to the angle. So the angle will change every time. And as we know, the angle is in radians, so we need a small value, which we got here. As you can see here, we got 0.147, and we add that to this. And you'll see it working in action in a second. We can then copy this, and we can then go here and say D if they want to go right, and then right for the right arrow key, and then KP6 if they want to go right. And in this one will of course be minus. Cool. Let's test this out. So if I were to run this, and of course we don't do anything yet because we have to go here into the main file, and we have to say player move. So right here, player move. So it should execute this every time this update runs, which is like a lot. 60 times a second, in fact. Run this. You'll notice I can now rotate. So that's pretty cool. And it takes me a full second to do a full rotation. Now, of course, if your FPS fluctuates, like you have 30 FPS, then the player might actually rotate faster than a second. So that's why they like using the FPS. But for right now, that's the easy way out. And we don't really use DT at the moment, but we can later. Nice. Now let's add a movement so the player can move up and down. Now we were not going to add the keyboard bindings for this in here. We're going to do it out here. The reason for that is because we will be using that for more than just the player. Anyhow, so then we can go if self.thrusting, and we set that up here, which is just true or false. So if the player is moving, or if the player is trying to move, so if they press W, the thrust will be true. Then, and here we want to start moving the player. So self.thrust.x, and this thrust.x is set here, is equal to itself, whoa, and then we can go plus self.thrust.speed, and we get the speed from here, which is 0. And it shouldn't be 0 now that I think about it. It should be 5. You know, you should give it at least some speed. So the faster you make this, the faster the player will move. So the higher this is, the faster the player will move. And here we can say times math.cos self. And this is just to kind of nerf the speed. And we can actually remove this in a second. And then divided by FPS. And then we can copy that again, and this time for y. And then we still everything the same, but here we can go minus, and then we do sin, and there. Now currently won't do anything, so let's try to implement that. So right here, between the load and update, we can say function love.keyPressed, and we can say key. And this will allow us to add a key press. Then we can say if the key is equal to W or, and now we can add a bunch of extra options. Yet again, you only need to add one. I just like to give choice. And here we have 3 options. One that will be the up arrow on the keyboard, and then KP8 for 8 on the numpad. If it's one of those 3, then player.thrusting equals true. So it will make the player thrust. Now we play it, we don't really get anything. And the reason for that is because we're not applying this thrust. We should apply this thrust to the x position. So self.x is equal to itself plus self.thrust.x. So you should apply the x amount of thrust to this. So let's just copy that and do the same for y. Now if you run this, as you can see, he moves, but he just kind of moves out of the screen first of all. And as you can see, also just constantly speeds up. That is because thrusting is always on. Now it would be even worse if we were to remove this right here, because that nerfs it a lot. So let's go here. And now if we were to run this, as you can see, he moves up super fast. And even optionally in the wrong direction. But yeah, so this just nerfs it to be slower and moves to the correct direction. Alright, and you can play around with that. Next up, we need to be able to slow down the player. So else, then we can go if, and you could make this an else if you wanted to, but I like to just go else and then if inside of it. Self.thrust.x, if that is not equal to 0. So the thrust x is still running. And the same with the y. So or, because if the thrust x and y is not 0, that means thrusting is still continuing. And we can go here also not 0, and that should be y. Then we should decrease it until it becomes 0. So self.thrust.x is equal to self.thrust.x minus friction times self.thrust.x. So the higher this friction we set here, as you can see there, the faster the player will stop. And of course divided by FPS. And we can do the same for y. Cool. Now let's implement that. Because currently when we press the key, we set the thrust to true. But it doesn't do anything after we set the key. We should actually tell it to stop thrusting at some point. So let's go here. So if the key, instead of pressed, we can go key released. And this means once this key is no longer being pressed, so being held in, we want to turn this to false. Cool. Now we can run this. Let's see. And as you can see, he moves much slower and he actually stops. So if I go like that, he will stop at some point. Now just to give you an example, if we were to go here to friction and up that to, let's say 1.7 and then go, then as you can see, he stops a lot faster. So the player now just almost immediately stops because the friction is so high. If you want to do the real space game, you can make the friction something like 0. Now, he will always just move forward. And this is how Asteroid actually is. The player never actually stops. So this friction just says how fast the player should stop moving. 0.7 I found to be a fairly decent value. It's not too fast and it's not too slow, but anywhere around that will work. Cool. The last things we need to do is we want to reset the color. So if any color changes happen, we want to reset it. So love.graphics.setColor and then 1 1 1 1. So it's all visible and it's all white. And then of course we want to actually, just for debugging purposes, show the FPS. So love.graphics.print love.timer get FPS and then 10 10. So it will print the FPS right here around the top. Now if we run this, we can also see your FPS. Comment down below what FPS you are getting. And yeah, that is that. We added the player and the player can now move. So we have this. Oh gosh, my bad. That's a bug we might want to fix. Okay, there we go. You see the player moves. And the player stops at some point as well. We should also at some point just implement something here so the player can't go off the screen. But yeah, and that's that. Thank you all for watching. I hope you all enjoyed and that I didn't lose too many of you with all of this math we had to do. Thank you all for watching. I hope you all enjoy and I'll see you all again in the next Love2D tutorial.